Multiple choice question 14 in chapter 5 review is a very interesting question. It says the function f such that, and we've got a parameter here, a to infinity maps to reals for f of x equals log to the base e of x squared. Now log to the base e of x squared is in fact a composite function, and so the x values that are allowed here have an implied domain. So we need to just double check the domain that we have here. So I have here that the x is going to be an element of, what can we put in here? Okay, so we can put any real number into x squared, and from it we'll get real numbers that are positive as well as the set of 0. Now all of that except for the 0 can go into the log function here. So our implied domain for this function needs to be whatever the real numbers are in here that excludes the output of 0. So from this, our restricted domain is going to be real numbers, excluding the set of 0, because we don't want 0 going into x squared, coming out as a 0, because we can't take the log of 0. So we actually have a restricted domain here. And because we've got real numbers that we can put into the function, the graph actually looks a bit weird. So you have your normal log graph, and therefore all your positive values of x. And then on the other side of the y-axis, you'll get a perfect mirror image. Because, for example, if this was -3, and this was 3, and I haven't drawn it very well, they should be perfect mirror images of each other, then this value here, the y value for that, should be the same as the y value for that. I'm just going to fix that up because that's annoying me. Okay, so that gives us the graph of the function that we can work with. And so what the question is asking us to do is to look at possible values for a. So I'm going to take possible values for a and I'm going to mark them on our graph. So our first one is that a could be any value from -infinity to 0. So I'm going to lay this here. So that green section there is any of the possible values that a can have. Now, the question asks us for which of those sets of values for a could we have as the domain for our function so that it will have an inverse function. So to have an inverse function, it has to pass the horizontal line test. So here's my horizontal line. At the minute, completely unrestricted, you can see that the function log to the base e of x squared fails the horizontal line test. That horizontal line is touching the function twice. And so it won't have, with an unrestricted domain, it won't have an inverse that is also a function. So we're going to try and see if we can restrict values within a and see if it passes the horizontal line test. So I'm going to pick up my domain of a and we're going to try the answer, option A, from -infinity to 0, to see if that actually is an answer. So our domain could start anywhere from 0, and that's fine because our allowable values of a start at 0. And if the a value was 0, you can see that we have a function here that, just using this little bit here to the right, will in fact have an inverse function. The problem is option A includes any value along that green line, and now you can see that we start to have issues with, if the a value, for example, was -3, then you can see that our horizontal line is touching the graph in two places, here and here, for a as being -3. And so option A isn't a possibility. So we move this out the way, move our horizontal line out the way, and now we're going to try option B. Option B says negative infinity to -1, which is there. Now, if A is any value within there, the domain of the function could be anything from here all the way along here. And you can see that the horizontal line would still be cutting that graph twice. So that's not an option either. Option C is negative infinity to 1. So that's that bit there. So values of A are going to be from negative infinity all the way down to 1. Any one of those is possible. If we then look at the domains, possible domains that fit that, that's okay. At A is 1. But as soon as we get down to here, as soon as we pass that x-axis as values of A, we're in trouble again. It's touching the line twice. So option D. Option D is from A values from 0 to infinity, which is out this way. Now, our domain could be anything from here, anywhere out this way continuously, and you can see that that gives you a function. If you're just using this domain here, that gives you a function that passes the horizontal line test, and so it will have an inverse that's also a function. So the answer to this question is D.